So there are a couple of, quote, special issues that often arise in this type of problem. The first is that supply does not equal demand, like we saw in our example. When supply does equal demand, we have what is called a, quote, balanced problem. When the two are unequal, we call it an, quote, unbalanced problem. The solver in Excel is smart enough to handle these situations by simply altering the right-hand side of the affected constraint. So, what if Des Moines increased its monthly capacity, or its supply, to 250 units? We now have more supply than is demanded. So what would the final answer look like? Well, if we continue to minimize cost, then at least one factory will not ship all of its supply, resulting in inventory buildup at that factory if we continue to produce at full capacity. The second issue that often arises is that a shipping route becomes closed or no longer desired for use. There are two ways to handle this issue. First, you could simply put a high cost on that route and resolve the problem in Excel. The cost should be high, but not astronomically high, to avoid numerical precision issues. In our example, a cost of $99 would easily keep us from using a route. In fact, I would probably put it even lower than that. Another way to handle a closed route is to remove the decision variable from the problem. Depending on how you have it set up in Excel, this may be easy or it might require a bit more effort. You should try using our example to explore both an unbalanced problem and a closed shipping route problem. And that about wraps it up for Module C, Transportation Modeling.